Hi everybody, this is Unit 4, Lesson 4, Congruent Triangles. So period 7, you're going to see this on January 28th, 2021. And if you're in periods 2 and 6, you'll see this on January 29th, 2021. Remember, you can print and copy this Google slide show. You can also print your notes, but remember to please fill in the Google slides for both today's classwork and your homework, which will also be on Google Slides, separate activity, and we'll talk about that towards the end of the period. So, some review, again, congruent figures. The goal, you slide one figure on top of the other. So I'll give you an example. Basically, in the end, let's say you have this first triangle, slide it over, and it's directly over the second triangle. So that's the idea. Goal having congruent figures. It might be something like this. So even if the direction is different, your goal, there's a way you can turn it so that the first one slides over the second one. So that's the purpose of that idea. Again, corresponding vertices must be in the same order. That's your congruency statement. Same thing with the sides. Your sides of the triangle must be same order for those two triangles or any shape in that manner to be congruent. And again, order matters. Again, one more time, here's our triangle. AB, DE, 1, BC, EF, 2, and CA, FD, 1, 2, 3. And then regarding the arcs, angle A, single arc, B and E, double arc, F and C or C and F, triple arc. Again, notice the order. ABC, or triangle ABC is congruent to triangle DEF. And again, if you want to, you can write your letters A, B, C. You write it over D, E, F. And that'll help you determine which angles are congruent to each other and which sides are congruent to each other. Four of your 5 triangle congruences didn't show up the best, but side, 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 your sides are congruent. Single, double, triple hash mark. Side angle side, first side angle, then second side, same thing. Here, angle, side angle, first angle, side, second angle, and then angle, angle, side, first angle, second angle, then side. We also talked about the triangle congruence for the hypotenuse leg. I won't see this too much, but the only difference is you have to have your hypotenuse, which is usually your longest side, across in the right triangle, or right angle, I should say. And then, of course, two sides, or the hypotenuse for the first triangle is congruent to the hypotenuse of the second. And there's at least one leg congruent to same leg, or congruent leg, corresponding leg on the other. Then your two triangles will be congruent. But this is the only time you have to have a right triangle in order to have the side, or hypotenuse, leg, and right angle. Talk about the shared side as well. Might help us. For instance, BD. That's our shared side for this triangle, overall triangle. Two smaller triangles share BD. Here, on the long side, AD is the shared triangle side for both. BAD is CAD. This E is just the point of intersection between BD and AC. That's all. Shared angle. In this case, ACE, BCD. They're sharing the right angle in this case. Vertical angles, again, always congruent. So BCA will be congruent to ECD. And of course, these two are vertical angles. That means they're automatically equal to each other. You could say similarly, BCD will be congruent to ECA. And then the parallel lines, they form alternate interior angles. For instance, ACD, CAB, and an idea might be trace. For instance, ACD, you start at A, go to C, go to D. And for CAB, start at C, go to A, go to B. And you could also say angle CAD, so CAD, which is this angle, is congruent to ACB. This angle. Notice how double arc, single arc. These are alternate interior angles because remember that these lines right here are going to go forever and ever. They still go on. Forever and ever and ever. Same thing here. Goes on forever and ever. And over here. And these lines sort of will too. But that will help us when we see. That's where we get our alternate interior angles. That's where we get the relationship. And then in both cases, your shared side is AC. Other rules to remember, vertical angles are congruent. Talked about it once before, 105, and then the 75. And what does 105 plus 75 equal? You need to fill in that blank. And you should know it's 180. Because remember, 105 and 75, that's a linear pair, always 180. So either going this way or this way. Now, alternate interior angles, again, here were a couple examples. Angle D is congruent to angle E. Alternate, that means opposite side, but inside, alternate interior. And I'm just going to put the symbol, but I'm going to put a lowercase e because usually they do numbers. And similarly, C and F, both inside but opposite, alternate interior. Remember that was inside and opposite. It might be an idea. So a lot of these activities that we're going to be doing are going to be basically tidbits and pieces we've learned from earlier this year. So again, angle E and angle F, I mean C and F, I'm sorry, are congruent. E and D are congruent. And then another one, angle bisector. You have your 48-degree angle, angle bisector, 24 and 24. So smaller congruent angles because, again, one way you bisect something, split it into two equal sections, parts, in this case, two angles, 24, 24. You don't see it too well, but there's a blue ray right here. That's your angle bisector. No. Highlight that. There we go. Segment bisector. Similar to an angle bisector. The only difference is a line segment is being split into two smaller congruent segments. So this line DC is a segment. It's a segment bisector right here, point M. A and B. So now we know that AM and B, they're going to be congruent. That's from the definition. Or we could say AM is congruent to MB, but that also means their values, actual values. So if, let's say, A to M is 30, let's say 30 kilometers, M to B must also be exactly 30 kilometers. It's always, always, always. If I give you a midpoint, I say that's your midpoint, the segment to the left and the segment directly to the right equal to each other. They're congruent. Now we also have a perpendicular bisector. So that's basically perpendicular bisector. Remember the mirror image? We sort of have a mirror image taking place. So they're saying PM bisects AB. And they're also going to tell us MA is equal to MB. So that means they're also congruent. Therefore, if you drew, let's say we started from point B, P rather, go to B, from point P to point A, the length of the distance from P to A is the same as from P to B. So I mean, and then the other thing is AMP, this angle right here, AMP, and again, one thing, trace. So if you see angle AMP, A is where you start, find A, go to M, and then M tells us, oh, we have to go to P. There you go. Now, these two angles, AMP, BMP, same thing. BMP, start at B, you go to M, then you shoot up to P, and they are both right triangles. Right triangles. And that box tells us 90-degree angle. Same thing here. Box, 90-degree angle. Now, the one thing that's new that we have to learn is a reflexive property. And basically, it's quantity, object, or item which is set equal to itself. For instance, numerical value 8 equals 8. Variable example T equals T. Measurement of the line segment dB is equal to dB. So let's say, and then given this, we can say dB, the line segment, is congruent to the other dB line segment. And given that, you can do this. Mark it 1, 2, 3. And once you do that, this can help us because now we see that we're going to start from 1, 2, 3. So we start at D, go to A, then go to B, go back down to D. So that's triangle. In fact, I'll make it blue. So we go up, D to A to B. So you're kind of going 1, 2, 3. D to A to B, B to D. So this blue triangle is D, A, B. We can say DAB is congruent to. Start at 1, B. You go to C, B, C. And from C, you go down 2. You get to D. And then D, go 3. Back to B. And then notice how D and B, and actually in the end, B and D, they're the congruent angle to each other. Let's say if these two triangles broke off separately. You would have something like this. B is over here. D is over here. C is there. On here. Still B. You're still D. But you have to go to A. Again, it's not my best picture, but that's the idea. Especially when we start dealing with these triangular congruences again. Notice which angles or vertices match with each other. So for instance, A and C. They're going to match. And then from there, well, be careful because this angle B matches with that angle D. Vice versa. This angle D corresponds to that angle B. And again, it goes down to triangle congruences, like the order, and so on, how we label our triangles. All right, so now what we're going to do, given these recent new rules that we've learned, flexive property, perpendicular bisector, angle bisector, segment bisector, vertical angles, and alternate interior angles. It's going to help us now with the new information for today. So if we look at example 1, a lot of it's going to be explaining. Now they're going to give you a lot of some information, quite a bit of it, or a lot. And then from there you have to deduct, okay, what do I have, what do I need, what's given to me. So for instance, they gave us AB, it's the side here, is congruent to CD, right? Now they're saying BC is congruent to AD. Okay. Right now, I'll label this as the 2 hash marks. And this is going to be 1. Those are given, those are given. Now, look at this. CA and AC, they share a side. That's the reflexive property because both triangles in the end are sharing that same side. So you could say, for instance, this triangle split apart. ABC, and then similarly, it's not the best, but A, D, C. Again, notice 1, 1, 3, 3, 3, and then of course 2, 2. But again, this is going to help you when you set up your triangles, like who's congruent to what and your triangle order. So in this case, I'm telling you, in the end, ABC is going to be congruent to CDA. And again, notice how we went from 1 to 2 to 3. Same thing here, 1, 2, 3. From C to D to A, back to C. Which happened here, C to D, D to A went back to C. Similar to A to B, B to C, and then from C, you flip back to A. So this checks. So we've proven that the two triangles are congruent by side, side, side. Okay, number 2. AE is congruent to CE. Okay, they both have 2 tick marks, so plus that's given. That's a good thing. They say AB is congruent to CD. That's true too, as they were given 1 tick mark. Now they're also saying E is our midpoint. So that's given. E is your midpoint. Now since E is your midpoint of BD, we could say that BE is congruent to DE. And basically this is because this is the definition of a midpoint. Also, because since you're at the midpoint, it forms 2 congruent sides. 2 congruent, correction, segments. So since now we notice, oh, again, E to A to B, so I went from 2, 1, 3, same thing, 2, 1, 3, E to C to D, everything matches, because again, that's going to be the key. So this is the goal. We want EAB rather, to be congruent to ECD, but we have to follow the directions. From E to A, it's going this way, and then A is going to continue down to B. So basically we went from E to A to B, and then B is going to return to E. Similarly, here you start at E, going to C because that's the 2 tick marks, and C goes to D, and then last D goes to E. And then now we got 2 things. EAB is congruent to ECD. Again, side, side, side. Sides are congruent. So now, number 3, when we have given AD and EC are parallel, and then that's from the arrows. That's how we're going to prove. If you have arrows, that's going to prove it. Because that's going to help us with these angles, and I'll tell you why. So now we also have this line segment BD is congruent to BC. So now we need to prove ABD and EBC, those two triangles, so ABD and EBC are congruent. And here's how you do that. Well, what's going to happen is, since we have parallel lines, since these lines go forever and ever, we notice that angle D and angle C now it should be angle ADB and ECB, but we'll just do single for now, because notice how we get angle C, angle D. Since it's only one type of word about that's inside, we can get away with saying this. These two angles right here are congruent. Because no matter how way we go, if we go from BDA or ADB, same angle. ECB or BCE, same thing. So that's why we can get away with just the single letter for D and C. And again, these two are congruent because of alternate, I'm just going to abbreviate, interior. So alternate ALT, interior, INT, and then this symbol's angles. But now the next part, what we're going to do, this is going to help us when we name the triangle. The second one, we start at A, go to B, and then we go to D. So that's the blue line. And then the black line, EBC, start at E. So this point was E. Go to B. And then from B, head to C. And in this case, these two are going to be congruent because they're vertical angles. I'm just going to abbreviate VERT for vertical. I'll write it out. Vertical angles. And then, of course, that means this angle and this angle. So now we have enough information to say these two triangles, ABD and EBC, are congruent because we have an angle right here. Another angle here, and the side in the middle. Same thing here. Angle, side, angle. All right, number 4. So now they gave us O is the midpoint of MQ, and it's also a midpoint of NP. So since we have this midpoint, O, we could say MO, OQ, they're congruent because I was going to bisect that segment into 2 equal parts. So the midpoint, so we could say definition of the midpoint So that's the idea. Splits it right into two congruent segments. And then they're also saying, same definition, you can just repeat. So whatever I'm going to write, whatever I wrote here, you could also rewrite in this box too. For box number 4, an O will be congruent. So OP. So now we have angle MON. Start at M, go to O, down to N. Vertical angles with Q, OP. So in this case, these are vertical angles. And from there, since they're vertical angles, because since those two angles are congruent, then we can say MON, so 1, angle 2, is congruent to Q. It's 1 hash mark, arc 2 for the 2 hash marks. Those two triangles, MON and QOP, are congruent because of side, angle, side. There's your side, there's the angle, there's the side, and vice versa. Side, angle, side. So SAS, SAS. Now, one rule we wanted to talk about was the corresponding parts of congruent triangles are congruent. We kind of seen that a little bit. So now to prove that parts, sides or angles of triangles are congruent to other parts, two parts of other triangles, first prove the triangles are congruent. So that's the key. We need to show everybody triangles are congruent. Then you can say the corresponding parts of congruent triangles are also congruent. And they're just going to use the CP-CTC. So basically, give you a quick, very basic. There you go. Triangle 1, triangle 2, and then let's say A, B, C, X, Y. So if we use any triangle proof, let's say so we have X, Y, Z, A, B, C. They're congruent. A is congruent. X, Y, Z. There we go. So ABC is congruent to X, Y, Z. Now, what you do here is we see, since what will happen since we found out that these two triangles were congruent, we're going to just say, we're going to make it up by saying angle, side, angle. And what you can do is, oh, wait a minute. We've seen this before. Remember when we were trying to find the missing triangle for the third angle? Well, angle C and angle Z. Once we prove this, we can, then you can say, okay, C and Z are congruent. Or you could say AC, XZ. So this has to be first. Then you can do your angle C. It's congruent to angle Z. Or AC. It's congruent to XZ. And again, look at that order. C and Z, same spot. A to C, first to last. X to Z, first to last. That's how we can make these connections with our angles and line segments. All right. So now what we're going to do, we need to figure out, we're saying now AB and DC are congruent. We're also going to say AD, AC are congruent. So we need to prove how is this guy, angle A, congruent to angle C. We don't know that yet. That's the goal. We're going to figure out how are those together. They're congruent. This isn't too bad because you already see that AB and CD, one side of the triangle, they're congruent. AD and CB, or ADBC, the second side is congruent. Now, here, notice that BD is for both sides of the triangle. This is your third segment. That's because of the reflexive property. In fact, I'll type it in. Reflexive property. Tells us those two are congruent. And then from there, two triangles are congruent because ABD, 1, 3, 2, and then CDB, 1, 3, 2 as well. That's going to be a side, side, side. And then, since those two triangles are congruent, notice here for this last one, AC. Since we found out these two triangles are congruent, the corresponding parts of the congruent triangles are also congruent. So these two triangles are congruent. Angle C and angle A correspond to each other. They're going to be congruent as well. And that's of that CP, C, T, C theorem. We kind of saw it before. We had angle, 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 angle. We knew what this angle, that angle, same here and there. And in this case, since they share the side, that'd be another way we could have done it. But we didn't know the measurements of measurement of BDC or BDA. We didn't know that. We don't know those angle measurements, but we did know about the sides. And since you can use side, side, side to prove the triangle, from there, then you can prove the corresponding angles A and C are also going to be congruent. Number 6. Again, PN. So this one right here. That NP bisects MNO. So once this is the case, that's going to help us. And in fact, I think in one of your homeworks or one of the last problems, this is actually going to lead us to number 3. But they also told us that PN bisects MNO. They're also telling us that MN, ON are congruent. Now going back to this first one, PN bisects MNO. If that's the case, M and O gets divided into MNP and ONP. O and P. So that's a definition. This one I'll give you. That's a definition of the angle bisector. Definition of the angle bisector. Now from there, NP is congruent to NP. So, boom, there you go. And that's for the reflexive. And then from there, angle MNP. So 1 arc 2 ONP. 1 to the arc and 2. And that's because we have a side angle side. And then of course, that tells us since we have two triangles that are congruent, now we can say that MP is congruent to OP. But that's after. So the only way you get a CP-CTC is by way of a triangle congruency. That's the only way you can get CP-CTC, after a triangle congruency. If you don't have a triangle congruency, then you cannot switch these two around. Can't do that. Once we declared it here, then you can do this. And of course, it'll match because M to P, 1 to 3. O to P, also 1 to 3. Now, number 7. Angle A. Angle B are congruent. AE, BE congruent. Now, this one, the case for angle AED that's going to be congruent to angle, oops, that should be BEC. Sorry about that. That will be fixed. BEC. So we go this one. They're going to be congruent because of vertical angles. And once you have the vertical angles, then we see, oh, wait a minute, AED, BEC, they're congruent because they have what we call the angle side angle rule. Again, I should have marked this as 2, because here it was marked as 1. Or we could have put, how about we'll do a second arc B, second arc for A, so we don't get confused. So we went from 2 arcs down the segment to the vertical angle, and vice versa. 2 arcs, line segment, single angle, vertical. Again, two triangles are congruent because of angle, side, angle. Here's your angle, side, angle. And we'll mark it. Same thing here, angle, side, angle. And then ED is going to be congruent to EC. Again, it goes back to the CP, C, T, C. Again, notice the difference. Once you prove this, then you can get to this. But again, you need the triangle congruence. So we have to prove the triangles are congruent. So we're going to say that again and again. So again, first, prove triangles are congruent for using CPCTC. Now we're going to go over the homeworks. So for period 7, you're going to use the notes from 128. It's going to be due a week from your class. And then periods 2 and 6, it's going to be due Friday, the 5th. Again, don't forget, everybody, there is a quiz 1 week from this class. So remember, period 7, this is your quiz. That's a quiz day. And similarly, quiz for 2 and 6. So be up to date with your homework. We're gonna go over. I'll give you some hints on the homework problems, and then we're gonna finish. So, for instance, problem 1. I told you the steps. Now, I think on a quiz, you'll be given the steps, but then you're gonna have to fill in the blanks. You have to fill in the blanks with these with either the triangle congruence or if it's the CPCTC. So for instance, this problem told us YA, BA are congruent. All right, given. Now they're saying angle B and angle Y. It's also given. But now, given this diagram, we can say that angle BAC, so we're going from B up to A, and then down to C, is congruent to YAZ. Now the reason being they're vertical angles, so that's automatic. And we're going to go in this particular order because you have your single arc Y, single arc B, so they have to be in the first position. And then we went from, in this case, B to A or Y to A, and keep the A is in the middle, and then you go from Y to A to Z. So, and similarly, you go from B to A to C. But now we have a triangle congruence because angle, side, angle. And similarly, angle, side, angle. That's it. Whoops. And now since these two triangles are congruent, then we can say these two sides will be congruent. Again, it goes back to this has to happen before this with the CP, CTC. Basically, I think for all four, I think in the end, you're going to have a CP, CTC. So number two, similar to number one, OLM and O given. In fact, they're right angles. So you could say this. Also, they say LMO is congruent to NOM. All right. Now we also know one other thing. We have a reflexive property. So therefore, since you have an angle, and side, let me know what which triangle relationship or congruency will we use here. And then again, since these triangles are now congruent, L to O, N to M, those sides are also congruent. So as a result, LO and M, we see from this triangle congruence, the relationship. So just like before, you can use that CP, C, T, C on that blank. So you have your triangle congruence here, and then once that happens, and you can use the CP, CTC rule. Okay, number three, I kind of cleaned it up a little, kind of bunched it. So XZ, QY, bisect at this midpoint here, W. So W is the midpoint of XZ. W is also our midpoint of QY. So you could say XW, ZW are congruent. You could also say QW and YW also are congruent. Again, notice the direction we're going. So, and then in the end, angle XWY, so we went from 1 to 2, we kind of went in this direction. So this angle is congruent to, and notice we're going from Z to W to Q. This angle so again, that's because vertical angles are congruent. They're vertical angles because they were formed at an intersection. Vertical angles across from each other, congruent. So given that's the case, you can say XWY, that triangle, is congruent to ZWQ because we have a side, angle, side. So there's your side, angle. Oh, angle's not coming up the best. Side. So side, angle, side. And therefore, since these two triangles are congruent, again, Q and Y, even though they were flipped, but Q and Y are in the same spot. Therefore, in the end, that's also going to be a CP, CTC. And then your last homework problem. M is the midpoint, AB. So AB goes from all the way across. And we're also saying AP, BP are congruent. Now what I'm going to do, Since M is the midpoint, this is going to lead directly to the definition of the midpoint. Breaks them into two congruent line segments. So that's why if you have the midpoint, yeah, AM and B or BM will be congruent. That's a midpoint, automatic. We also said that AP, BP were congruent. So again, indicate that that's given. Now, given this triangle, we see that, oh, we have a PM, PM. Remember, that's a reflexive. And then, oh, well, what do we know? We have 1, 2, 3, 1, 2, 3. So, in that case, APM, so I'm going from point A, point P to M, so could have also said MAP, but we'll go APM and BPM are congruent because, well, side, side, side. And therefore, since this happened, now we know why angle A and angle B are congruent. And again, that goes back to that CP, CTC. Okay, so those are you. So again, you only have 4 homework problems. You follow the rules of this video. And I will tell you exactly what you need to do for the homework. Also, save your homework, notes in your homework. So these last 5 slides are going to be separate. They're going to be at your homework, but it's still an assignment, just like your classwork's an assignment. Now, do not forget, use your homeworks, use your notes to help you prepare for next week's quiz. Again, we will do some studying, we will review, and get you practice, and we may go over some homework problems as well during that time period, and then you'll have your quiz a week from today. Thank you, everybody. Hope this works. Hopefully this helps. I'll see you soon.